All right, let's look at this bell ringer. What's the slope and what's the y-intercept in this equation? Negative 1/2, very nice. Very nice. Okay, so if we're going to graph this, okay, and I apologize, your copy, the lines did not come out super great. The copy machine and I were fighting. Where do we start? Are we starting with the negative 1/2 or are we starting with the 4? Okay, so the 4. So we're going to go up 4 on the y, and then, what do you know about this slope? It's negative, so we're going to do rise over run. So we're going to go down 1 and over 2. And if you want to do that a couple of times so you have several dots, feel free. And then here is our line. Oh, that's kind of straight. So we've done that a lot. So we're going to continue to draw our lines, but now we're going to look at them with inequalities, okay? So there are a lot of similarities to what we just did and an inequality, so let's talk about that down here. Similarities are, they are solved the same way. Equations and inequalities are solved the same way. The only difference is instead of an equals, you have an inequality symbol, or vice versa, right? We always graph the y-intercept first and then count the slope, okay? We always count that rise over run from the y-intercept. Both of these, whether it's an equation or an inequality, will create a line. Here are the differences. Just like when we did inequalities way in Unit 1, we had open and closed circles, and then we also had arrows, right? So on our y equals mx plus b inequalities, we are going to have a dotted or a solid line. That's going to be the equivalent of our open and closed circles. And then we are going to shade on either side of the line. That's going to be like our arrows, because inequalities have infinite number of solutions. So just like when we drew the arrows, we could say, well, this could be an answer, this could be an answer. We had all these different numbers that could be answers. We're going to run into that same thing. So the shaded region is going to be where our solutions are. So if we break these down into pieces, I'm actually going to start at the y-intercept. I'm going to go right and then move to the left. So because that's how we normally graph it. So the y-intercept is where we cross the y-axis. So we cross the y-axis and we're going to plot that y-intercept. Anybody remember what is called the other word for the x-intercept? 0. Good. Okay. So after we do the y-intercept, we're going to do our rise over our run, which is our slope. And that's going to help us plot that second point. So again, those are going to be just the same as like what we did on the bell ringer. This is going to be the new part. We're either going to shade above or below that line, depending on our symbol. And we need to decide, is our line going to be dotted or dashed or solid? And we will shade our graph. So those are going to be the two new pieces. Where do we shade? Above, below? What kind of line are we going to draw? Is it dotted? Is it solid? And we're going to talk about what those mean. We made a table like this in Unit 1 when we first started talking about inequalities. So I want to make that for you so you can refer back to it if you have any questions about what kind of line you need to use or where you need to color. So we're going to have our dotted line and our solid line. If it is dotted, it is going to be a greater than or a less than, not or equal to. If it's solid, it's going to be or equal to. So that's going to kind of help you remember. If it is or equal to, you've got that extra solid line. You're going to have a solid line on your graph, okay? We will shade. Let's think about this. If these are less thans, where do you think we need to shade? Above the line or below the line? Below, definitely. And if it's greater than, we'll shade above. All right. So let's put this into play. We have y is greater than negative 3x plus 2. And then it says which ordered pairs are solutions. So we're going to do the ordered pairs part second. First, let's focus on what does this graph look like? So let's talk about what is our B, because that's where we always start. What's our B here? 2. What's our M? Negative 3 over 4. Okay, so let's draw this line. So we're going to go up 2. And again, I'm sorry the lines didn't come out really well when I copied it. Down 3 over 4. That's my slope. We could do that more than one time if we needed to. All right. Now comes the new part. We have to look at this inequality. It is a greater than. So what kind of line do I need to draw? Am I drawing a dotted or a solid? Dotted. I am drawing a dotted or a dashed. So instead of just drawing one solid straight line, I'm just going to kind of pick up my pencil, make a dash. So you could draw a solid line and you could erase parts of it. And now comes the shading. It says greater than, so above or below? Above. All right, and we're going to color all of that space above. It doesn't have to be, super fancy or anything like that. Just to kind of show that this is where all of our answers are. This is saying that every coordinate in that shaded region would make that inequality true. Okay? Now, just like when we had open and closed circles, and that determined if we were including that value as a solution, same thing with solid and dotted. On a dotted line, these coordinates are not solutions because it is a dotted line, right? We are not including those dots. If it was a solid line, yes, it absolutely would be an answer, okay? And we're going to look at that. So we need to graph these 4 points, and we're going to see if any of these fall in our shaded region, and if they do, they are solutions. So -1, so we're going to go left 1 and down 3. Is this a solution? No, it is not. It is not in the shaded area. 0, -2, no. 1, 0. That's way over, that's going to be over to the right a little bit. Yes or no? No. -3, +2. No, none of these are solutions. Okay? None of them fall in the shaded region. Now, can you give me one that is a solution? Can you give me a coordinate in the shaded region? 7, +1. Let's look. Okay, so if I'm going to graph that, I'm going to go across 1, 2, 3, 4, 5, 6, 7. +1 absolutely is in the shaded region. Very nice, very nice. Does anyone have another one? 4, 6. So across 4 and up 6-ish. Very nice. All right, so those are going to be solutions. Great job. So I do want to show you how you can figure out the answer to this without making the picture. You have your yellow calculator, and when we did solving equations to check our answer, we plugged it in and we looked for a true statement, right? If we did it right, if it wasn't, then we got false. We can do that same thing with inequalities. So I'm going to come up a little bit. I don't know if you have space. You can write it if you do. And do we want to use 7-1 or 4-6? Pick one. 4-6. All right, 4-6. So remember, this is x and this is y. So we're going to plug those into our original inequality. So in your calculator, we're going to type 6. And then to get our greater symbol, we're going to use control equals. Control equals. And then we're going to do -3 over 4 times my x was 4 plus 2. So type that in and see, do we get a true or a false? We get true. So that means that yes, in fact, this is a solution. So if we didn't want to make the picture, we could still plug it in and see if yes it is or no it's not. Okay? If we used one of these A, B, C, or D's, we would get a what? We would get false. Okay? All right, last two examples, and this first one is a word problem. So, looking for keywords, this high school student is working at 2 different restaurants and can earn no more. Okay, so no more means less than or equal to. He can he can work exactly 25 hours, or he can work less. The most he can do is 25 hours. So they've given us this inequality. So we're going to graph it. So we need to start at the 25. That's our B. Now our M is a -1. So you could count down 1 over 1. I'm actually going to count down 5 over 5 because -5 over 5 is also -1. And that's just a nice, easier point to see on the graph. I've got an or equal to. What kind of line am I going to have? Solid. Very nice. And then where are we going to color? Above or below? We are going to color below because it's a less than. So all of the hours that we're shading right here, these are all possible combinations that this person could work and get his 25 hours. Okay? So give me a solution. So give me one coordinate that would show how many hours he can work at Bill Miller's and how many hours he can work at Las Palapas. 5 and 15. Very nice. Definitely. He could work 5 hours at Bill Miller's and 15 at Las Palapas. Let me ask you about this one. Could we do 15 and 10? Is it on the line? What kind of line is it though? It is a solid, so this is going to be a yes. We only have a no if it's on a dotted line, kind of like open and closed circle. All right, last example, and really there's actually no math involved. If you notice, all of these lines look identical, so really this is all about that inequality. So you need to think about what kind of line for less than. We should have a what? A dotted. And we should shade above or below? Below. So if we need a dotted line, what can I eliminate? These on the right-hand side. And then which one is shaded below? The one on the top or the one on the bottom? The bottom. Very nice, very nice.